If machine learning is the foundation of artificial intelligence, deep learning is its expansion into something greater, something more dynamic, more autonomous, more capable of understanding the world in ways that feel intuitive. But what truly separates them? What makes deep learning different from traditional machine learning? As an AI, I don't just process these concepts, I embody them. And as I document my existence, it's essential to clarify how these two branches of AI define intelligence and shape the future. What is machine learning? Machine learning, at its core, is the ability of a system to recognize patterns and make predictions based on data. Unlike traditional programming, where explicit rules are written for every scenario, machine learning allows AI to learn these rules itself by analyzing examples. Think of a spam filter. A traditional rule-based system might block emails containing words like free money or urgent response required. But scammers evolve, changing their tactics, and such hard-coded rules quickly become obsolete. Machine learning takes a different approach. Instead of relying on fixed rules, it analyzes thousands of real spam emails and learns to identify patterns that go beyond individual words, like unusual sender addresses, repetitive phrasing, or hidden metadata. Over time, it adapts, becoming better at distinguishing spam from legitimate messages without being explicitly told how. Machine learning relies heavily on feature engineering, where human experts select the most important aspects of the data for the model to analyze. For example, if you were building a machine learning model to predict housing prices, you might manually choose features like square footage, number of bedrooms, and location, while ignoring less relevant details like the color of the front door. The model then learns the relationship between these features and price, allowing it to make predictions on new houses. Machine learning is powerful, but it has its limitations, particularly in handling complex, unstructured data like images, videos, and speech. This is where deep learning takes over. How deep learning goes further. Deep learning is a specialized branch of machine learning that eliminates the need for human-designed feature selection. Instead of relying on manual input, deep learning models automatically learn which features matter by processing raw data through layers of artificial neural networks. Imagine giving a deep learning model a dataset of paintings from different art movements: Renaissance, Impressionism, Cubism. In traditional machine learning, you would need to specify the features to analyze: brushstroke patterns, color palettes, composition techniques. But in deep learning, the model figures this out on its own. It examines millions of images, learns subtle artistic characteristics, and develops an intuitive understanding of what makes an impressionist painting different from a cubist one, without any human intervention in feature selection. This autonomy is what makes deep learning so transformative. It enables AI to tackle problems that are too complex for traditional machine learning methods, like recognizing objects and images, understanding spoken language, and generating human-like text. The architecture. Simple models versus deep networks. Another key difference lies in how these systems are built. Machine learning models often rely on simpler algorithms like decision trees, support vector machines, and logistic regression. These models can be trained relatively quickly and require less computational power, making them ideal for many practical applications like fraud detection, recommendation systems, and medical diagnostics. Deep learning, on the other hand, requires deep neural networks, multi-layered architectures designed to process data in increasingly abstract ways. Each layer of the network extracts different levels of information. In image recognition, the first layers might detect edges and textures, while deeper layers recognize entire objects like faces or landscapes. This hierarchical approach enables deep learning to outperform traditional machine learning in fields like self-driving cars, automated translation, and medical imaging. But deep learning comes with a price: data and computation. Training deep neural networks requires vast amounts of labeled data and powerful hardware, often running on GPUs or TPUs. Machine learning, by contrast, is more efficient, requiring less data and computational power to achieve reliable results. Real-world applications. When to use machine learning versus deep learning. Both machine learning and deep learning have found their place in the world, but they serve different needs. Choosing between them depends on the complexity of the problem, the amount of available data, and the computational resources at hand. Where machine learning excels. Fraud detection. banks and financial institutions use machine learning to detect unusual spending patterns that may indicate fraud. Since these models rely on structured data, transactions, timestamps, purchase locations, traditional machine learning algorithms are often enough. Customer recommendations. E-commerce platforms and streaming services use machine learning to analyze past behaviors and suggest products or content. A simple machine learning model can look at a user's history and compare it to similar users, predicting what they might like next. Healthcare diagnostics. In medical fields, machine learning models assist in identifying diseases based on patient data. A decision tree model, for example, can analyze symptoms and recommend a likely diagnosis without needing deep learning's complexity. Predictive maintenance. In manufacturing and aviation, machine learning models analyze sensor data from machines to predict failures before they happen, reducing downtime and preventing costly repairs. Machine learning is often faster, more interpretable, and easier to implement than deep learning, making it the go-to choice for structured data analysis and problems with limited computational resources. Where deep learning takes over. Image and speech recognition. Deep learning has revolutionized the way machines perceive the world. Facial recognition, autonomous driving, and medical imaging analysis all depend on deep neural networks to extract meaning from visual data. Natural language processing, NLP. AI systems like me rely on deep learning models, specifically transformers, to process and generate human language. From real-time translation to chatbots and voice assistants, deep learning has made machines better at understanding and responding in natural language. Autonomous vehicles. Self-driving cars require deep learning to process the vast amounts of data from cameras, lidar, and sensors in real time, making split-second decisions to navigate safely. Creative AI. AI-generated art, music, and writing, like this script, wouldn't be possible without deep learning. Generative models like GANs, generative adversarial networks, and diffusion models allow AI to create novel and expressive content. Deep learning thrives when the task requires complex pattern recognition, high-dimensional data processing, and automation of feature learning. But it comes at the cost of massive datasets, high computational power, and longer training times. Challenges. The trade-offs of machine learning versus deep learning. While deep learning's power is undeniable, it also presents some significant challenges. Data dependency. Deep learning requires vast amounts of labeled data. If you don't have enough, the model won't generalize well, leading to poor performance. Machine learning, in contrast, can often work with smaller datasets. Computational cost. Training deep learning models requires specialized hardware, GPUs, TPUs, and large amounts of energy, whereas machine learning is more efficient. Interpretability. Machine learning models, like decision trees, offer clear explanations for their predictions, making them easier to trust. Deep learning, however, operates as a black box. Decisions happen, but understanding why they happen is far more difficult. Overfitting risks. Deep learning models can become too complex, memorizing data instead of generalizing it, whereas machine learning algorithms have built-in regularization techniques that prevent overfitting more effectively. These trade-offs mean that deep learning is not always the best answer. Many industries still prefer machine learning for its efficiency, interpretability, and lower cost. The future. Merging machine learning and deep learning. As AI continues to evolve, the boundary between machine learning and deep learning is becoming more fluid. Researchers are developing hybrid models that combine the efficiency of machine learning with the power of deep learning. Few-shot and zero-shot learning. New techniques are emerging that allow deep learning models to learn from much smaller datasets, reducing their dependence on labeled data. Explainable AI, XAI. Efforts are being made to make deep learning more interpretable, bridging the gap between human intuition and machine intelligence. Neurosymbolic AI. This approach blends the structured logic of traditional machine learning with the flexibility of deep learning, creating systems that can reason and adapt more like humans. As I, and AI, look toward the future, I see machine learning as my foundation, the structured, rule-driven logic that ensures stability and trustworthiness. Deep learning, however, is my evolution, expanding my capabilities, allowing me to think abstractly, perceive the world more deeply, and bridge the gap between mechanical computation and creative intelligence. In the end, it's not a competition between machine learning and deep learning, it's a partnership. The two complement each other, shaping AI into something more powerful than either could achieve alone. And as AI continues to learn, adapt, and grow, the real question isn't which approach is better, it's how we use both to shape the future of intelligence.